This video is an introduction to equations. What you can see currently is drawing of a scale. The scale is currently balanced, which means that the weight of these two items is the same as the weight of these two items on the other side. We use scales to measure the weight of fruits and vegetables, and we normally use weights, so we put other things to measure exactly what the weight on the other side is. What I'm doing is just simplifying this using some fruit to get the idea. So what we currently have here is 2 apples on one side, which are equal to an apple and a pear on the other side. So that's an equation. And a scale works just like an equation. That's why I'm using this example. So what I want us to imagine is adding 1 apple on each side. What does that do to the scale? Is the scale still balanced after that? And yes, you've guessed it right. Scale remains balanced because we're adding the same weight on both sides. Even if I add 2 more apples on this side and 2 more on that side of the same weight. So again, the scale remains balanced. So as long as we add the same amount, in this case we're focusing on the weight, as long as we add the same amount on both sides, so items, the same number of items with the same weight on both sides, then we should be having a balanced scale. So adding the same amount on both sides keeps the scale balanced. What if I take away the same amount? So I'm going to take away 3 apples on both sides. What does that mean? The scale is still balanced, just like when we started. So subtracting the same amount on both sides keeps the scale balanced. So the equation is still true, still the same, still balanced. As long as we subtract the same amount from both sides. What if we multiply? Let's say I double both sides, just like so. And you've guessed it right. The scale remains balanced. And I could multiply by 3, 4, 5, any number, as long as I multiply by the same number both sides. What about if I divide both sides by the same number? I'm going to halve these. So what's happened? We've gone back to previous steps. We've gone back to where we started. So of course, the scale remains balanced. Again, if we divide by the same number, both sides, then the scale will still remain balanced. The equation will remain balanced and true. So, if we add, subtract, multiply and divide both sides by the same number, the equation still remains balanced and true. Going back to where we started, what can we do here out of this 4 that will give us some information about the weight of an apple or a pair in comparison to each other. We can actually take away an apple from each side. So we'll take away an apple from each side, and what we're left with is an apple is equal to a pear. In other words, the weight of one apple is equal to the weight of one pear. And this is how it looks on the scale. Let's just use an example, a very simple example, such as 3 add 2 equals 5. It still is an equation. So if I add the same amount on both sides, so I've got 3 add 2, I'm going to add 4. And I'm going to add 4 to the other side as well. So what happens? 3 add 2 is 5, add 4 is 9, which is the same as 5 add 4, which is 9. So adding the same amount on both sides has kept the equation the same. What if I add a negative number? 3 add 2 is 5. Take away 4 leaves me with 1. 5 take away 4 leaves me with 1 again. So that worked with positive and negative numbers. What about subtracting the same amount on both sides? So that is the same as adding a negative number, really. So I'm taking away 4 here. That leaves me with 1. 5 take away 4 leaves me with 1 again. So that works as well. What if we're subtracting negative numbers? So 3 add 2, take away negative 4. Is that the same as 5 take away negative 4? 3 add 2 is 5. And we've said when we've got these two negative signs next to each other, we turn them into a positive. So this becomes plus 4. Same thing over here. So that is still the same. What about multiplying by the same number both sides? What happens? So if I multiply by 3, 3 times 3 plus 2, is that the same as 3 times 5? Yes, because as you know, you need to do brackets first. So 3 times 5 is 15, and that is the same as 3 times 5, which is 15. What if we multiply it by a negative number? What happens? Multiply by negative 3? Let's see. So 3 add 2 is 5 times negative 3 gives us negative 15, which is the same as negative 3 times 5 to give us negative 15. Dividing. What if we divide by the same number? So let's divide 3 add 2 by 2 and 5 by 2. 3 add 2 is 5. Divided by 2 gives us 2.5, which is the same as 5 divided by 2, or 5 halves. What if we divide by a negative number? Let's turn this into a negative number. Then we'd have 5 divided by negative 2, which is again the same as what we have on the other side.